velocities formula पण दिले होते.
Correct. Pitch line velocity formulation I have given you, and the two types we have seen. Before that, I tell you just in case of the beam strength, we have developed one equation, that is FB, beam strength is equal to sigma BBMY. In that, one by one, we have seen what is the meaning of Y and all that. After that, we have seen about the wear strength, in which we have calculated dPBQK, that is about the wear strength. And then we have directly moved toward the effective load, that is on the basis of a dynamic load condition. In case of the velocity factor, we have seen, and for that velocity factor, we have used the factors like Ka, Km, that is application factor and load distribution factor. How it came? As per the chart. If they are not included in your examination, you will have to take one. That's it. Now, in case of the dynamic loading, here I have explained what is the role or how the three parameters are helpful for selecting the value of velocity factor, that is Kv. And this factor is selected on the basis of grade, that is international standard grade, methods of manufacturing of that particular gear, and on the basis of pitch line velocity. For that, we have seen the equation of pitch line velocity pi dn by 60, and in that the diameter and rpm of that particular will have to take always in terms of a pinion. So that is very important. So up to this part we have covered. Now we have written the title. There are the two parameters or two conditions for estimation of a dynamic load. One, we have seen the velocity factor. In that we have written this: F effective is equal to Ft max, tangential force, which is maximum tangential force, divided by velocity factor, that is Kv. And how it can be selected from the chart. So Ft max already we have derived, that is multiplication of K, application factor, distribution factor, and tangential load acting on a gear pair, divided by velocity factor. Here I told you the Ft can be directly calculated by P by V. V is nothing but pitch line velocity, and we are going to calculate that by pi dn by 60, and d is nothing but diameter of pinion, rpm of pinion. And if these values Ka and Km is given, then it's okay. Not given, we'll have to take one. Now Kv is factor directly given by the in examination or in numerical. If not, they will give the chart. So how to select, I told. So this is about the dynamic load condition, and this was actually first method to calculate the dynamic load, that is effective load, in case of gear pairs are moving. So this point we have covered, and it is also called as a Barth factor. Barth factor. So this Kv. So that also we have seen. Now we'll move toward the second method, which we called as, write down, estimation of dynamic load by Buckingham's equation. By Buckingham's equation. Second method for dynamic load by Buckingham's equation. Buckingham's equation. Now we have seen wear strength. Now this Buckingham's equation is suggested for dynamic load only. Dynamic load. So in that, again, for dynamic load, it means we need to calculate effective load, and this effective load can be different as compared to this velocity factor. But we have to calculate the effective load on the basis of Buckingham's equation. So he has given the equation, that is, he has considered, instead of taking Kv or velocity factor, you will have to take a dynamic load plus Ft max. So this equation he has given. So we have to go by this equation as per the Fd and Ft max. So just write down this title, second Buckingham's equation, and under that title write down, this is the final stage of gear design. This is the final stage of the gear design, म्हणजे शेवटची स्टेप आहे gear design, where we know the gear dimensions. We know the gear dimensions. we know the gear dimensions, and errors and occurs error occurs between the teeth, of course, gear and pinion, between the teeth. The dynamic load, the dynamic load can be more accurately found, more accurately found by using Buckingham's equation, by using Buckingham's equation, by using Buckingham's equation. So below that, write down. Therefore, effective load F effective is equal to, directly write down. In case of Buckingham, F effective is equal to FD plus FT max. FD, write down below that. FD is nothing but it is a dynamic load. FD is nothing but it is a dynamic load. Notation FD, and we know it, FT max, maximum tangential effective. So no need to write, but we'll have to proceed. Just write down this equation. Now we'll have to understand what is dynamic. We'll have to understand what is dynamic load. Now, as per the Buckingham suggestion, he has given, instead of velocity factor, you can select from the chart. Instead of going the chart, you will have to select the dynamic load which I have derived. So he has given the information, he has given the formulation, and the dynamic load he has given. I'll write here 21V. V is nothing but pitch line velocity in bracket face width into deformation factor plus maximum tangential load occur on a gear pair divided by 21V same plus under root of same BC plus FT max. So he has given this equation. So he said that, he suggested that you can directly calculate analytically dynamic load by this equation. So one by one we go through the terms what are included in this equation. So just write down the dynamic load suggested by Buckingham's is dynamic load is suggested by Buckingham is, so write down FD is equal to FD is equal to 21V numerator 21V in bracket BC plus FT max divided by 21V plus square root of BC plus FT max. As we know, write down V is pitch line velocity. Pitch line velocity. Correct? Write down capital C, what is called as a deformation factor. Deformation factor. Capital C, it is called as a deformation factor. Correct? Now rest terms you know it. Small b face width you can write again, no problem. Small b is nothing but it is face width. It is face width. Small b face width. Rest things you know it very well. Now here new term is introduced, that is deformation factor. Now what is that deformation factor? Name itself indicate deformation means part or product going to deform. So if product is going to deform, then our role is to avoid that deformation. So how I can avoid that deformation? By using material only. By using material. If material is aluminum, then there is a deformation. If material is steel with proper thickness, no deformation. Understood? So this term is again related to the material point of view, as we have seen the terms for K, load stress factor. We have seen for steel it is 0.16 times BHN by 100 bracket square, that we have seen, correct. For cast iron it is 0.21 times BHN by 100. For cast iron gear and steel pinion it is 0.18 times BHN by 100. That was according to material. So here also the deformation factor is totally depends on the material. So below that just write down, to avoid the deformation, to avoid the deformation, to avoid the deformation during working, we need to strengthen material, strengthen the material. So condition first, same as that of previous. When, write down, when gear is व्यवस्थित लिहा, when gear is made up of steel and pinion is also made up of steel. When gear is made up of steel and pinion is made up of steel, the value I'll directly tell you, and that we'll have to use at the time of examination. That is C is equal to 11,500 error. That is small e is nothing but error. So this value defined by the Buckinghams. So here notation त्याच्या खालीच लिहा, E is errors in pinion as well as gear. Correct? Errors occur in gear pair. असं म्हणा. आला का इथेपर्यंत बाळांनो?
Yes, sir.
Okay. Errors occur in gear pair. Now, what is that error? So here write down, the total error is always occur, that is EP plus EG. First understand and then write. Now, what was this error? So this error is nothing but it is error in the gear teeth profile. Now, at the time of meshing, we cannot predict the meshing will occur with respective teeth of pinion as well as gear in same manner. There will be the chances of error occur at the terms of the height or addendum point of view, at the time of on the point of tooth thickness. So error will be occur, and that error is always in micron. So it is not visible, rather this kind of the error is always in micron. So total error occur, I can calculate whatever be the error in the tooth with respect to pinion as well as the gear. So by adding this, I'll get the total error, and this E value after calculating error, I will have to put here in this equation, in C equation, deformation. ठीक आहे, तर या पद्धतीने आपण बघणार आहोत. So below just write down the total error occur in a gear tooth profile. Total error occur in a gear tooth profile. Write down, small e is equal to EP plus EG. Error in pinion, notation पण लिहा, and error in gear, and whatever with the addition that will have to add in deformation equation, and then I'll get the deformation value C, and that C value again I will have to put here in FD equation. I'll get FD. That equation I can put in F effective, I'll get effective load. समजते? या पद्धतीने तो सिक्वेन्स असणार आहे. As they have mentioned, this is the last step. हे झालं एका मटेरियल साठी, स्टील साठी. चलो सेकंड कंडिशन, when gear and pinion, second condition write down, when gear and pinion is made up of cast iron, when gear and pinion is made up of cast iron. So I'll write directly in short. So you can write from your end, when gear and pinion is made up of cast iron, CI is made up of cast iron, then deformation value is, that is deformation factor C is equal to, deformation value is, write down, 8,900 times error. For steel 11,500, and for cast iron 8,900 error Newton per mm. Newton per mm. This is very important. हे काय पाठ करायची गरज नाही, हे आपण सोडवेल एक्झाम्पल मध्ये आपल्याला ऑटोमॅटिक क्लिअर होतं. डोंट वरी. So because these values are defined by that scientist and we have to use as it is. This is the condition for cast iron. Second condition. Correct. Third one I'll write. Of course, when gear is made up of steel and pinion is made up of perfect alignment, gear is made up of cast iron and pinion is made up of steel. So we have taken same condition for K also, load stress factor. Then the value of deformation factor C is equal to, the value of deformation factor C is equal to 10,000 error in terms of E. In terms of E. आणि पहिली कंडिशन पण इथे लिहितो तुम्हाला मी 11,500 error. Of course, this is also Newton mm. Newton mm. Here, so as per the material, if the material is steel, 11,500. If the material is cast iron, we'll have to take 8,900. And if the material is perfect alignment, that is cast iron gear, steel pinion, we'll have to take 10,000 of error. So this is the important one. And whichever be the applicable as per the given data, we'll have to use here this FD, C value, here and here. Correct. If this value get wrong, or if this value you have calculate wrongly, then all answer, design answer is totally wrong, 0 mark. So त्यामुळे ते बघायचं की मटेरियल कुठलं दिले, काय कंडिशन वापरले, and according to that we'll have to select the value of both deformation factor, that is capital C. लिहून घेतलंय सगळ्यांनी? ओव्हर. घेतलं का रे बाळांनो? ईश्वांकू, स्वप्नील, शुभम, विक्रम.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is about the dynamic load, and through which what we are going to calculate, through which we are going to calculate effective load. So they will ask, calculate effective load by using velocity factor. Then I will have to use the equation of effective load in case of velocity factor. If they have asked calculate effective load by using Buckingham's, so I'll write FD plus FT max. So difference, you must understand this. These are the two equations, and we'll have to check which effective load they are interested or they want as per the requirement. Correct. So these are the two things which we have studied according to Buckingham. Now the question is for error. As we know, the total error occur in the system we have defined, that is error in pitch, error in pinion as well as error in gear. So in case of the pinion, what happened? The pinion errors are, or all the errors are in microns. Correct. So whatever with the answer come, will have to multiply by 10 raised to minus 3, which is in micron, EP plus EG. This will be the total error. My error आता micron मध्ये पण आहे म्हणताय तुम्ही. So if error is in micron, how engineer can realize this error. So for this error, we'll have to use again design data book to find out this micron error. So I'll show you as per the design data book how to find out the errors. So just next heading, error occurs in spur gear design. Error occurs in a spur gear design. So see, here is the chart. What this chart suggested, this is pitch error, correct? As per the standard, that is international standard IS grade, we'll have to decide. And this pitch error in micron, these are the conditions they have given. See, 7 to 12 grades they have given, then 1 to 6 here. So these are the standard chart to which we'll have to use. Suppose in the examination they have given use grade 4 and they will give you this value. आपल्याला या व्हॅल्यू काही पाठ करायच्या नाहीयेत, या व्हॅल्यू डायरेक्टली दिलेल्या असतात त्या त्या ग्रेड नुसार. तर आपल्याला एवढंच माहित असलं पाहिजे की ग्रेड नुसार या व्हॅल्यू रिफ्लेक्ट होत असतात. सपोज विल टेक द एक्झाम्पल फॉर 5 ग्रेड, म्हणजे इथं आलं. सो एरर इज 5 प्लस 0.45. Now what is this 5? This is called as a tolerance factor, correct? Tolerance factor का consider करायचा? Because at the time of meshing there will not be any misalignment, त्यामुळे टोलरन्स फॅक्टर हा कन्सिडर करतो. एक लक्षात घ्या, जेव्हा मी गिअर पेअर मॅन्युफॅक्चर करतो ऍट द टाइम ऑफ पिनियन मॅन्युफॅक्चरिंग, ते मी सेपरेट करणार आणि गिअरचं मॅन्युफॅक्चरिंग सेपरेट करणार, भले ते एकाच कंपनीत मी करत असेल, पण सेपरेटली मॅन्युफॅक्चर करताना ड्रॉइंग रीड करताना देअर माइट बी चान्सेस ऑफ चेंजिंग ऑफ टोलरन्सेस. म्हणजे 0.03 असेल आणि इकडे 0.04 झाला असेल तर त्याला आपण काही करू शकत नाही, ते चालतं, बिकॉज दॅट वी कॉल्ड ॲज अ एरर, करेक्ट? त्यामुळे हा टोलरन्स फॅक्टर घेतला जातो आणि त्याचं स्टँडर्ड व्हॅल्यू आहे एम. एम म्हणजे मॉड्यूल, मॉड्यूल प्लस 0.25 टाइम्स डायमीटर ऑफ दॅट पर्टिक्युलर, करेक्ट? 0.25 टाइम्स डायमीटर ऑफ पर्टिक्युलर. म्हणजे फॉर 5 ग्रेडला माझा आन्सर येईल E is equal to 5 plus 0.4 into M plus 0.25 D. हे किंवा दुसरे काय ग्रेड विचारलं तर त्या पद्धतीने फक्त इथं टोलरन्स फॅक्टरची व्हॅल्यू मी M plus 0.25 अंडर रूट D हीच ऍड करणार. सो दिस इज अबाउट द एरर. सो यू कॅन जस्ट राईट डाऊन फॉलोइंग आर द व्हॅल्यूज, असं लिहा, फॉलोइंग आर द व्हॅल्यूज ऑफ एरर. Following are the values of error. Write down as per the grade. 2 कॉलम करा आणि सगळ्याच लिहून घ्या, कारण प्रत्येक गिअरला हेच ग्रेड आहे आणि याच एरर असतात. सो स्टार्ट विथ 1 किंवा ठीक आहे वरून चालू करा, बॉटम 12, 11, 12, 11, 10, 9, 8, 7 and you have to write the pitch error in micron. Pitch error in micron. IS grade 12, 11, 10, 9, 8, 7. So for that 63 plus 5, 5. 5 is nothing but tolerance factor. लिहून घ्या, झालं की सांगा, पुढचं चार्ट आपण बघू. झालं का?
झालं सर.
Okay. Chalo. Next is related to 1, 2, 3, 4, 5, 6. Just write down this and below that tolerance factor 5p. So don't write p. It is just 5. यांनी या केस मध्ये पिनियनचं दिलंय तर आपल्याला जायला नको. Only 5 you will have to write. So this kind of the error we'll have to consider. Pi is the tolerance factor. करेक्ट. आता या केस मध्ये लक्षात घ्या, कन्फ्युज व्हायचं नाही. आपण टूथ प्रोफाइल मध्ये 5 is considered as a pressure angle म्हणलेलं. And in case of the error, phi is tolerance factor and that is always m plus 0.25 times under root diameter. झालं का रे हे लिहून? Over 11.
Yes, sir.
ओके. बाकीचे योगिता झालं का?
Yes, sir.
Okay, no problem. So this will be the value of error. Now I'll tell you how to implement or how to use this equations in case of error point of view. See here, if they have asked to calculate the error, in that case what to do? Suppose here the value of error, I'll take a random value. Right now I don't remember this one. Okay, the chart is with me. Suppose they have given for grade 7. What is the value? 11 plus 0.95 tolerance factor, and this is the error. Correct. In that case, how I can calculate the error? As we know, error is nothing but error in pinion and error in gear. So one individually I will have to calculate. Error in pinion is equal to 11 plus 0.9 in terms of pi is nothing but tolerance factor, m plus 0.25 times under root d. So this will be the error, but I have written here for pinion, so I will have to write here also pinion dp. This is very important. And error in gear I will have to calculate same value 11 plus 0.9 module plus 0.25 under root dg. Whatever the answer come, it is in micron. So E is equal to that value. I will have to add EP plus EG, and that value I will have to put the equation of FD. FD च्या इक्वेशन मध्ये किंवा डिफॉर्मेशन फॅक्टरच्या C च्या इक्वेशन मध्ये मी तेव्हा मी कॅल्क्युलेट करू शकतो किंवा टाकू शकतो. तर या पद्धतीने आपण हे बघणार आहोत. तर तुम्हाला at the time of solving the numerical you will get the idea how to do the things. Last part of this, write down safety against bending and wear failure. पहिला असेल आहे safety against bending failure. Safety against bending failure. Safety against bending failure. So I'll write what is mean by this. So I have written A point, safety against bending failure. Safety against bending. ठीक आहे, आता इकडे लक्ष द्या. सेफ्टी अगेन्स्ट बेंडिंग. बेंडिंगला कोण रिप्रेझेंट करतं? बीम स्ट्रेंथ. अंडरस्टूड? बीम स्ट्रेंथ इज रिप्रेझेंट. So beam strength. In case of the beam strength, I will have to compare this safety with respect to, of course, safety चा part येतो तिथे येतो factor of safety into effective load. This is very important. This is in case of bending. आता बेंडिंग कधी घ्यायचं किंवा कसं कळणार मला? तर मी काय करणार, जी काही बीम स्ट्रेंथ मी कॅल्क्युलेट केले आणि जी काही वियर स्ट्रेंथ आय हॅव कॅल्क्युलेटेड, तो विच एव्हर बी द वीकर. समजा वियर स्ट्रेंथ स्ट्रॉंग आहे, समजा याची व्हॅल्यू आली 50 न्यूटन, फोर्स आहे ना 50 न्यूटन समजा, आणि याची व्हॅल्यू आली 100. तो या केसमध्ये वीकर झाला बेंडिंग. बेंडिंगला स्ट्रेंथनिंग करण्यासाठी आपण सेफ्टी घेतो, सेफ्टी अगेन्स्ट बेंडिंग. देअरफॉर FB is equal to factor of safety into F असं आपण घेतो इन केस ऑफ बेंडिंग. करेक्ट. आता F कुठला, वेलोसिटी फॅक्टरचा का बकिंगहॅमचा? सो तो दिलेल्या प्रमाणे घ्यायचा ऍज पर द स्टेटमेंट रिक्वायर्ड, म्हणजे स्टेटमेंट रिक्वायरमेंट. ठीक आहे, तर त्यानुसार घ्यायचा. कुठला घ्यायचा तो ठरवायचा. जर वेलोसिटी फॅक्टर दिला असेल तर इथे वेलोसिटी फॅक्टरचा येईल. जर त्यांनी डिफॉर्मेशन फॅक्टर दिला असेल तर ऑफकोर्स ते वेलोसिटी फॅक्टरचे कुठेच नाहीये इक्वेशन. So it is directly clear that we'll have to use Buckingham. हे झालं सेफ्टी अगेन्स्ट बेंडिंग फेल्युअर. सो जस्ट राईट डाऊन सेफ्टी अगेन्स्ट बेंडिंग फेल्युअर आणि त्याच्या खाली लिहा ऍज कम्पेअर टू, सॉरी, बाय कम्पेअरिंग, असं लिहा, बाय कम्पेअरिंग बीम स्ट्रेंथ अँड वियर स्ट्रेंथ. बीम स्ट्रेंथ अँड वियर स्ट्रेंथ. ठीक है, नेक्स्ट लाइन. व्हेन बीम स्ट्रेंथ इज वीकर. एक्झाम्पल दिले मी, वीकर म्हणजे काय, बाबा त्याची व्हॅल्यू कमी असते. इफ बीम स्ट्रेंथ इज वीकर, ऑफकोर्स कुणाच्या, वियर स्ट्रेंथ, देन we'll have to use, write down, FB, beam strength is equal to factor of safety into effective load. Factor of safety into effective load. हे कधी बीम स्ट्रेंथ वीकर असेल तेव्हा. आता तसंच लिहा सेफ्टी अगेन्स्ट फिटिंग किंवा वियर, सेफ्टी अगेन्स्ट वियर फेल्युअर. मी लिहिणार FW वीकर असतो तेव्हा, म्हणून FW इज इक्वल टू फॅक्टर ऑफ सेफ्टी इंटू F इफेक्टिव्ह. F इफेक्टिव्ह कुठला घ्यायचा ते स्टेटमेंट ठरवेल. करेक्ट. सो दिस इज द लास्ट स्टेप टू फाइंड द सेफ्टी अगेन्स्ट बेंडिंग और वियर. इथं पण तुम्ही ते सेंटेन्स रिपीट करू शकता बरं का, की बाबा कधी वियर स्ट्रेंथ घ्यायचा, व्हेन वियर स्ट्रेंथ इज वीकर as compared to beam strength, as compared to beam strength, then we'll have to take the wear strength, then we'll have to take wear strength. Clear? लिहिलं का रे इथपर्यंत? Is that over?
Yes, sir.
Yes, sir.
Okay. Now, this is all about gear design in case of spur gear. So, I'll revise the session, what we have covered in unit number 1. व्यवस्थित लक्ष द्या. पेजचं नोटबुक जे काय असेल ते पहिल्यापासून चालू करायचं. So, I'll tell you the formulas which we'll have to use for designing one by one for your understanding. तुम्ही काय लिहून घ्यायचं नाहीये. तुमच्या एंडला फक्त चेक करा, ते लक्षात राहील. So, I'll start. See, first at the starting we have used the module. Module is nothing but d by z in case of the terminology. Then we have seen circular pitch PC, pi d by z. यालाच आपण pi m पण म्हणतो because d by z is module. Then we have seen diametral pitch PD is equal to reciprocal of what? Tell me. Check करा, notebook check करा. Reciprocal of what? Module. Yes.
Module.
Correct. So this is module. So I can write z by d. So these are the basic terminology which we have seen. After that, we have decided the center distance also. Center distance equation तयार केलं. Basic equation was dp plus dg divided by 2. यालाच आपण कन्वर्ट केलं m into zp आणि सगळ्या गोष्टी आपण डिराइव्ह केलंय. m into zp 1 plus gear ratio divided by 2. Correct? हा center distance. Of course, हा mm मध्ये असणार. Then we have reached up to gear ratio. Gear ratio म्हणजे काय लिहिलेलं आपण in terms of teeth zg by zp, in terms of diameter dg by dp, in terms of number of rpm that is np by ng. Yeah, basic terminology we have seen. Then minimum number of teeth to avoid the interference. That derivation we have seen for the rack and pinion, and minimum number of teeth we have calculated, that is twice of HA addendum divided by m into sin square phi. Phi म्हणजे pressure angle किती घ्यायचा 20 degree. So that we have seen for the case of terminology. हे झालं पहिला पार्ट. नंतर आपण गेलो फोर्स अनालिसिस कडे. मी तुम्हाला रिवाइज करतोय विच फॉर्म्युलेशन अँड हाऊ वी हॅव कॅल्क्युलेटेड हे सगळं आपण बघितलंय. फक्त तुम्हाला रिवाइज करतोय. सो देन वी हॅव सीन द फोर्स अनालिसिस. फोर्स अनालिसिस मध्ये आपण पहिला बघितला बाबा टँजेन्शियल फोर्स असतो. टँजेन्शियल फोर्स काढला P by V असतो. त्या P by V ला कन्वर्ट केलं 2 pi nt by 60 pi dn by 60 टॉर्क बाय रेडियस. मग ते पिनियनचा असेल किंवा गिअरचा असेल ते डिपेंड्स त्या पद्धतीने जायचं. नंतर बघितला रेडियल फोर्स दॅट इज Ft tan ऑफ पाय हे आपण बघितलं. नंतर आपण बघितला रिझल्टंट F इज इक्वल टू स्क्वेअर रूट ऑफ हॉरिझॉन्टल फोर्स स्क्वेअर म्हणजे काय मी लिहिन इथं डायरेक्टली लिहितो आता. दॅट इज रेडियल फोर्स प्लस टँजेन्शियल फोर्स Fr स्क्वेअर प्लस Ft स्क्वेअर हे आपण बघितलं. ठीक आहे, इथपर्यंत आलो. याच्यानंतर आपण बघितलं की बाबा डिझाईन ऑफ प्रॉपर गिअर म्हणजे बीम स्ट्रेंथ. मग बीम स्ट्रेंथ मी लिहिली Fb इज इक्वल टू what we have proven mby by I and so that sigma b p m y प्रत्येकाचं सांगितलं. सिग्मा बी SUT by 3 असतो. का असतो ते पण सांगितलं इंड्युरन्स लिमिटवर. नंतर बी असतो 10 टाइम्स मॉड्यूलच असतो. वाय लेविस फॅक्टर असतो. लेविस फॅक्टर कशावर डिपेंड आहे टूथ प्रोफाईलवर. जर टूथ प्रोफाईल इज 20 डिग्री टूथ प्रोफाईल असेल लेविस फॅक्टर येईल 0.484 मायनस 2.865 डिवायडेड बाय झेड. जर इथं पी असेल पिनियनचा तर झेड नंबर ऑफ टीथ पिनियनचा होईल किंवा गिअरचा ऍज इट इज त्या पद्धतीने. ठीक आहे, दिस इज अबाउट द बीम स्ट्रेंथ. देन वी मूव टुवर्ड द वियर स्ट्रेंथ. Wear strength, which was the inbuilt equation, wear strength is equal to dp bq k. dp म्हणजे काय m into zp, b 10 times module, q ratio factor कसं घ्यायचं सांगितलेलं मी. So I'll write here. So ratio factor is twice of zg divided by zp plus zp. and if the meshing is internally done in between the gear pair, तर ते फक्त minus होईल. So I have written this Q is equal to, for external G, choice of ZG divided by ZG plus ZP. This is for Q. Then K is called as a load stress factor for material. If material is steel, cone, steel's a pinion, steel's a gear, then K is equal to 0.16 times BHN by 100 bracket square. हे पहिलं झालं. Then cast ironचं असेल cone, steel, material for pinion as well as gear. In case of that, K is equal to 0.21 times BHN by 100, correct, bracket square. And if cast iron gear and steel pinion, then we'll have to take K is equal to 0.18 times, right? K is equal to 0.18 times BHN by 100 bracket square, hardness by 100 bracket square. इथपर्यंत आपण we have seen for the K, and once we get this value, we'll get the wear strength. ह्याच्यात मी चेक करणार बाबा वीकर कुठला आहे, मग लास्ट स्टेप वापरणार वीकर अगेन्स्ट सेफ्टी, सेफ्टी अगेन्स्ट बेंडिंग अँड वियर, त्या पद्धतीने. ठीक आहे. तो वियर स्ट्रेंथ पर्यंत आलं. देन वी हॅव गॉन टुवर्ड्स द इस्टिमेशन ऑफ डायनॅमिक लोड. त्या डायनॅमिक लोड मध्ये आपण काय काय बघितलं, दोन फॅक्टर बघितले. एक होता वेलोसिटी फॅक्टर अँड सेकंड वन वॉज बकिंगहॅम्स इक्वेशन. वेलोसिटी फॅक्टर मी लिहिला डायनॅमिक लोडिंग मध्ये, जेव्हा गिअर फिरतो तेव्हा. तो डायनॅमिक लोडिंग मध्ये मी लिहितो हे बघा, एफ इफेक्टिव्ह इज इक्वल टू एफ टी मॅक्स म्हणजे के एम एफ टी डिवायडेड बाय के व्ही. हे त्याचं इक्वेशन झालं. के व्ही कुठनं घेणार, चार्ट वरून घेणार. एफ टी पी बाय व्ही किंवा टॉर्क बाय रेडियस जे काही दिलं असेल त्या पद्धतीने. के एम चार्ट और वन घ्यायचं जर दिलं नसेल तर. हा झाला डायनॅमिक लोडचा पहिला. सेकंड डायनॅमिक लोड वी हॅव टेकन बकिंगहॅम्स. बकिंगहॅम्स काय सांगतो, इफेक्टिव्ह लोड इज ऑलवेज ऍडिशन ऑफ डायनॅमिक एफ टी मॅक्स. हा डायनॅमिक लोड महत्वाचा. डायनॅमिक लोड म्हणजे काय, डायनॅमिक लोड म्हणजे 21 BC प्लस एफ टी मॅक्स divided by 21V plus square root of BC plus FT max. आता हे बी कॅपिटल नाही बरं का, स्मॉलच आहे, चुकून माझ्याकडनं झाला. दिस वन इज स्मॉल. फेस विड्थच आपली 10 टाइम्स मॉड्यूल ऑइल. ठीक आहे. मग ह्याच्यात मी तुम्हाला काय सांगितलं, सी कसा घ्यायचा. सी आता डायरेक्ट सांगतो, 11,500 11,500 फॉर स्टील, 11,500 फॉर स्टील एररच्या टर्म मध्ये. कास्ट आयर्न असेल तर 8,900 8,900 एरर. अँड इन टर्म्स ऑफ कास्ट आयर्न गिअर अँड स्टील पिनियन इट इज 10,000 एरर. हा इथं टाकलं मी. एरर कशी काढायची ते सांगितलं, त्याच्यासाठी चार्ट बघितलं, एफ डी मिळतोय. एफ डी मिळाला, इथं टाकलं, एफ इफेक्टिव्ह मिळतोय. ठीक आहे. आणि लास्ट स्टेप होत्या बेंडिंग अँड वियर फेल्युअर. मग त्याच्यानुसार जो काही वीक असेल बीम स्ट्रेंथ आणि वियर स्ट्रेंथ तो तिथं पुटअप करायचा. सो दीज आर द इक्वेशन्स फॉर्म्युलेशन वी हॅव सीन. हे तुम्ही मी सांगितलं तसं बघितलं का नोटबुक मध्ये. ओके. ठीक आहे. सो आय थिंक 11:45 इज ओव्हर. सो डू रिवाइज द सेशन. मी एक रिव्हिजन पण घेतले तुमची. आज स्वतः एकदा प्रॅक्टिस करा, फॉर्म्युलेशन लिहून काढा, so that from tomorrow onwards we'll start with the numericals. Okay, thank you.